I'm sharing the screen. Please let me know. Is my screen visible? Hello?
Yes, sir. Yes, sir.
Okay, thank you. Fine. So I guess last week we have seen this one, right? One RTL to bitstream design, right? So same thing, just so that we are like we all can have an experience on a physical hardware. So we'll be taking like a bit of a smaller design, and also we'll be doing hardware debugging. It's like a summary of what we have done as of now, right? So you can see here, this is the design specification. It's a 8-bit up-down counter. So it will have reset, it will have clock, asynchronous reset, the clock. This is system clock because this design will be implementing it onto the hardware. And the outputs will be blinking onto the LEDs. And we have this up-down control to make the counter up counter to make the counter down counter. Quite an easy example, but it is like it will show us many hardware aspects that we need to do, right? So my first thing is what to do. What are the things that we need to focus on when we will be implementing a design onto the hardware? So first, what we need to do is we should know which board I am using, or you can say which FPGA I am using. So if you have a board, that is well and good, and if you have an FPGA, that is also you can take it up. So board on or FPGA it is required. Next thing, the second thing is that we know, right? We have to download the master. XDC file. I'll show you how to download after choosing a board. And third thing is from the master XDC files itself, we should know at least the basic pin connection. And we should know about the specification of the board that will be there in the dataset. Specification of the board. So what this specification of the board means? So let's say I'm giving an example. I'm using this Z board, right? So this Z board is basically a zinc SoC. This is a zinc SoC board. Why? Because we'll be using this same board to implement ARM processor like embedded C codes, right? But here what we have processing system and processing programmable logic. That this part is FPGA. In this part, we will be implementing the counter.
Sir?
Yes, yes.
Sir, the screen is not changing, sir.
Okay, okay. Let me check again. Is the screen visible? Can anybody confirm? I've already shared.
No, sir. No, sir, not visible.
One second. Let me change my internet connection. Just give me a second. Yeah, let me know this time around. Is it visible? Hello?
Sir, not clearly, sir. Only white patch is there.
Okay, it is coming. It's loading up. I'm changing the slides. Are you seeing that? No, right?
No, sir.
I'm writing on the slide. Okay, okay, it's
Nothing
lagged.
visible, sir.
Okay, okay.
Now
okay.
FPG implementation is coming. Yeah, there's a lagging is there.
Yeah, that lag is there. Okay, okay. Let me change the network. Better. Yeah. Now, can you please let me know? Hello?
Yes, sir, visible, sir.
Okay, okay, fine, fine. So this is the
Yeah, visible,
board that
sir.
will be, yeah, thank you. So this is the board that we'll be using, okay? So first thing is we should know what is the specification of the board. So how to get to know? So first thing is that you can see this zinc SoC is made from this board is made from zinc SoC. The main heart of the device is the zinc SoC, and the board is made not from Xilinx. Xilinx have not made the board. This is third party company that have made the board. That means they have procured the zinc SoC chip, FPGA chips, SoC chip from Xilinx, and they have come up with this specification. So using this board, I can do connections, I can take pin configuration, all those things. So this data sheet you need to download. So how to download the data sheet? And this will be the same for any kind of a board, right? So first what you need to do is you need to go to and you have to check for Jetboard. Just you need to type here. So you can see you'll get, I'm going to Jetboard. So Avnet is the company who has made that particular Jetboard. So that third party option company will be providing the quick start guide. So here all the information will be there. Okay. So how, like all the peripheral information will be there, not in the inside the chip. It will be like outside the chip, how the inputs and outputs are connected. Certain demos will be there, certain example designs will be there, and certain information about the pin connections will be there. You can see here. So this is the board that I'm using. Okay. So I'm sending this link first of all, and I'll also send the link for the data sheet also. So for each and every board, this is the procedure that you need to go through. Okay. Now the main thing is that for now coming back to our application, what we need. This is my application, right? This is my application. So we can see here we need two switches to control up down, one switch, one reset. For giving the reset, we need one switch. We need a clock connection, that is a physical clock connection that we need. Then we have to have this count output. So count output is of 8 bits. So 8 bits, to represent that I need 8 LEDs, right? Now my question is, since I am working on this board, I know, I have seen the specification, I got to know my physical pin is of 100 megahertz. Okay, so that will be connected to my RTL code of the counter, right? So my counter will run in 100 megahertz, that is 10 nanoseconds. At every 10 nanoseconds, the count will change. Will it be visible in a hardware, like like from our eyes? Will that blink will be visible onto the LEDs if we map it onto the LEDs?
No, sir.
No. So
No,
what you
no.
suggest? Yes, correct. So what you suggest?
Clock divider.
Increase the
Correct. We have
frequency.
to, yes, we have to do frequency division. We have to do clock division. So here you can see this is how the hardware perspective will change. In simulation, no worries, I can see the count. But here, this you can see here we have to use a clock divider for hardware implementation. Correct. So this is the clock divider that we need to use. So you can see 100 megahertz. I am making it to 1 hertz, right? And I am using this reset is asynchronous. So that means if I am pressing the reset, the clock divider count and the reset counter count is also getting resetted. And also we have this up down control. So up down control is to select up or down, right? So this is the hardware design that we have to work on. But along with that, what we need? So what we need this RTL code. We can simulate it also, that is fine. We are going to bitstream generation. So we can simulate it. So we need the simulation. Sorry, we need the simulation. That is the test bench files, simulation files. Then one more thing is required. I guess you know, this is the Xilinx design constraint. That is physical pin constraints I need. So how to download that, right? So what you need to do, you can go to the same website and you can check in reference design. Just give me a second. Yeah, you have this quick start and this one in there also you can find. Or what you can do, just you type, you can type like that. For some boards, it is so popular boards is directly available, Master XDC, right? So directly you can download it. So what, or you can do what they have given. Yeah, so they have given Master XDC here itself. So from that website, you have to download the Master XDC file. The Master XDC file will be different for all this one, for all the different boards, right? Just let me check. XDC. Yeah. So you can see this is the Master XDC file. So that you need to download. So once you have downloaded, so I'll extract it. So what should the tool knows? The tool should know. You can extract it here. Yeah. So this is my Master XDC file. So what the tool knows? The tool should know the pin connection, right? So what is the pin number? So the main thing is that for, you can see the clock. So I know this is the Y9 pin. So package pin is Y9, right? So this pin number I should know. And from there I will be making the XDC file. So two things are required, that is the package pin and the IO standard. So they have defined the IO standard in one, in one go, but what is the preferred way is this. So I have provided you. So from this XDC file, the format is also there, the template is also there. You need to come up with creating our own XDC file. So this is the XDC file we need to create. So you can see here. So this is what I have created. So first thing I will be giving for the clock. So this hash means it's comment. Just to know that this two TCL commands is specific for my clock. You can see here. So this is the system clock, this is the package pin, and the package pin number is Y9. This is the system clock, this is the IO standard, and the standard is LV-CMOS 33. So all those things you need to provide. So for reset also I have provided. So for reset I have used a push button switch. One switch I have used. So for that particular switch, T18 is the number, right? So similarly, I have used a push button switch for this one, up down control. This F22 is the number, and this is the IO standard. And for 8 LEDs, you can see this I have standard. So what it will link? It will link with this. So this is in my RTL code. This is the name with what we have provided. So get ports I underscore sys underscore clock is my input clock. I underscore reset underscore async.h is my active high asynchronous reset, and data out count are the LEDs, right? So like LED outputs. So all those things we need to provide. So those things I have provided, and I have come up with the RTL code here. Okay. So this is my RTL code, and this clock. Please. Yeah.
So in that, yes, the master's list, what you are showing us, is it specific that those pins we have to take for system, clock, and all?
Yes, sir.
Any
Yes,
other
sir.
pins we can take?
No, you cannot take, because then it will be implementation error. Like whenever it will generate bitstream, then it, because those things you can see here in the hardware. I'm just showing the hardware here. Just I'm
no, sir. My point is, what exactly I mean to say that, for example, for clock, is there a specific pin or 2 or 3 pins are there? From that we have to take a new one?
No. So you can see here, these are all specific. So for a particular board, it will be specific. So for like whatever
I can't see.
No. Yeah.
I can't see your screen, sir.
Okay. Yeah, I'm so showing this one a video of the board. You can see my video is on. So okay. 1 second. 1 second. I'm turning switching off my camera, and I'm going to the data sheet of the board. That will be specific. So for this board, the specification will be of the pin numbers will be unique to this particular board. You cannot change the boards because it is hardware, right? So the clock has been defined to a particular pin. We cannot change that.
Okay.
Yeah, but you can say, let's say I'm giving an example. This is for JET board. So that board has one clock source, and that is connected to one pin. But there are boards that has 2 different clocks, but those 2 different clocks are also separated.
Okay.
So that is very specific to the board. And
no, I'm just confused that you're taking a package and package then pin. So I thought in package number of pins are there for clock.
No. Package, yeah. Okay, well, let me work. So you can see here, this package pin is the you can see inside a bank there are number of package pin. Correct? Inside a bank you can see there are number of package pin. So that particular package pin is one only. That will be specific.
Okay.
So you can see in bank 13, there is a package pin number Y9. So Y9 is specific for the clock source in case of a JET board. That won't change. If you are changing to another clock source, then like if you are changing this particular pin number, then it will not take the particular clock source, and it will be an implementation error.
Okay, then in the above one audio codec is there. So
yes.
Audio codec number of pins are there, which anyone we can take.
No. Audio codec will have, let's say in audio codec, there will be specific pin configurations, like let's say HDMI, or you can see here JA port. So in some, let's say for audio codec, this number of pins are required. For clock, only 1 pins are required, right? For audio codec, okay, this number of pins are required. So so if you want to connect this audio codec, so any like audio device, so those number of pins should be configured.
Okay.
Correct?
Okay,
So
sir.
let's say, yeah.
Got it.
Let's say I'm giving a simple example. I want to connect a 7 segment display. So for that I need 7 inputs, right? So out of this, these are peripheral inputs, generic peripheral inputs. I'll be using 7 inputs out of it. Those 7 inputs I'll be using out of it. So depending upon case to case basis, we need depending upon the requirement, we need to connect peripherals, but those peripheral pin configurations should be same.
Okay, sir. Got it.
Okay. So from those, but my main thing is the master XDC file. So from here you can see I have taken package pin Y9. Two things we need to take. One thing is this Y9 pin number. This is like pin number. Package pin is a pin number. And then what is the IO standard? So IO standard is 3.3 for that particular pin, right? So that thing also we can check it from the website, like from the datasheet, and you can take it up. So that format I have provided, right? You can see the XDC file. You can see that is what I have provided. So I have connected the clock of my design clock to Y9 pin, right? This Y9 pin is 100 megahertz. It will go to a clock divider. So clock divider, what it will do? It will count to a particular number. From the particular number, what it will do? It will create another signal. So this signal will be a 1 hertz signal. So let's say how I have connected. Just I'll give an idea of it, how I have connected, like how I have got this pin number. So this is a basic clock divider. So what clock divider does? It divides the clock. So what I am doing, there is basically a counter that is calculating to a particular number. In this case, the number is this. Why? Because I need to, let's say, this is my 10 nanoseconds clock. It's very small clock. It's coming at it's changing at every 5 nanoseconds, correct? So for every 10 nanoseconds, what I am doing, I am counting. I'm counting to a particular number. So I want to count till 0.5 seconds. Then I will again count till 0.5 seconds. So this 0.5 seconds in terms of nanoseconds become this particular number. Correct? This is the constant number. This is for, I have used a parameter y because if I want to make it for this one 2 seconds, I need to provide 10 here. This is 1 second, that's why I'm providing this value, right? So it's counting, and I'm sending this particular signal. What I'm doing, I'm generating it from a flip flop. But this is not a clock.
Again, hello.
Yeah.
Yes, how please. 1 nanosecond here 1 second, but again
yeah. Okay, fine. So let's say I want to make a clock divider. Okay, let's make of 1 second. So let's do that. So this is 10 nanoseconds clock. Okay, so this clock period is 10 nanoseconds. So how many times I need to calculate? So let's make a 1 second clock, let's say. So for if it is a 1 second clock, the time period is sorry, if it is a 1 hertz clock, the time period is 1 second. So the duty cycle will be how much? 0.5 seconds, correct? So for 0.5 seconds, this signal will be 1. Then for another 0.5 seconds, this signal will be 0. So what I need to do, I need to count till that particular value. So if I convert 0.5 second in terms of nanoseconds, how much it will become? Just you calculate it, you will get this particular number. Is it clear, sir, now?
Yes, sir.
Yeah. So now I am getting a signal, but this signal is coming from a D flip-flop. It is not a clock signal. I have to make it as a clock signal. Why? Because this will excite this particular counter. So this would be driven from a clock signal. So what I am doing, I am using this instantiation of this particular. This is how to instantiate. So I am using a clock buffer. You can see this is called buff G. That's why. And I am taking this particular signal. This is W underscore clock, and I am taking it out of the primitive. So how I will find this particular primitive? So what I need to do, I need to go to language templates. I need to take the primitive of the clock buffer. Then just what I need to do, I need to do named instantiation. Automatically, this buff G will be included. We'll see that. We'll see how to do that in the lab. And this output is going, I have made another module. You can see this is the module instantiation of the clock divider, and it is going to another module, that is the clock divider here. This is very basic clock, this is very basic counter, that is the reset with up and down count. I am incrementing and decrementing, that's it, right? So let's do the implementation. So what we need to do, we need to have the design file. Before that, we need to test it. We know very well how to test, just need to create a test bench, and this XZC file is important. Now I'll show you step by step how to go from RTL to bitstream. Okay, so let's do that. So here itself, I will create a folder. So I'll tell RTL to bit. I'm launching the tool. So I prefer like side by side you can also do, so that you can test it on the board. Okay. So if it's required, like we can arrange certain time slots whenever you are free. We can you can send us a request, and you can access the board in your free time, in like whenever we are in the office, and we can access the board through remote. So from remote also how to access that demo also will be giving. Okay. So I'm creating this project. First, I will show you how to do the XZC connections, how to check the DRCs and all. Then we can also do the same thing, right? So it's very basic. Just you need to include the files. That's it. All the files are provided. So this is a up, down count, right? Up, down counter I have done, created. So this is an RTL project we know very well. So I know which board I'm using. So directly I'm selecting this particular board. So the tool also knows what board I'm using, right? So that also I can see. Let's say I have, by mistake, I have given a separate pin number. So that also I can check. I'll let you know how to check. So this is the board that I have selected. Click on next, then click on finish. Okay. Now what I am doing, I am just adding the sources. So add and create design sources, add files. So I'm connecting the clock divider and the counter. This is just generic. Generic means a parameterized counter I'm giving, so that we can take it later. I'm first of all we are focusing on an 8-bit counter, so that I have taken. Okay, then finish. Along with that, I need to add the constraint file. Okay, so let's we'll do elaborate netlist to check how the structure has become. I'm just opening the elaborate netlist. Give it a second. I'm in the schematic. Okay, you can see this is the clock divider, right? So this is a big divider. That particular number you can see it has been converted, and it is dividing the clock, correct? And you can see here, this is the adder and subtractor depending upon the multiplexer. So it feels like the architecture is good enough, but you can see in the package there is no pin connections. You can see in IO ports also there is no pin connections. Now what I need to do, I need to add source. I need to add and create the constraint, add files. Now this is a constraint, right? So I have already provided you the XDC. We know, so same thing will be done for any kind of a Xilinx FPGAs. This is the same process you need to follow. Just the pin number and the IO standard. Those two things you need to provide for each and every input and output ports. It can be an audio codec, it can be a 7-segment display, it can be an HDMI port. For all those things, the same thing will be there. It can be a UART, it can be an SPI. Just you need to check the data set of that particular peripheral connected. The input output pins you need to map as per your design. Then click on finish. So once you have added, you can see automatically, I need to reload it once. So it's reloading. So any files you like upload, you need to reload it. Yeah. So here you can see, first we'll check here, automatically those connections has been done. You can see those connections has been done as per the requirement, and this is the IO standard that already we have provided. So this is a way to check in an Excel sheet format, what are the pin connections of the inputs and outputs, correct? And you can go to the device, you can see the schematic also. Yeah, sorry, in the package. So Y9 pin we'll see. So this is the input output pin, right? This is the connections of the input output pin. So I'll go to Y and I will select this Y9 pin. So here you can see already, since I have provided, you can see this has been reflected. So port system clock, it's connected to Y9. So these are the two information we need to check, right? So let's say I am not sure. There might be certain faults that I have made. So what I need to do, you have to see report DRC. You can see here, you have to click report DRC. So once you click on report DRC, you can see it will check as per the rules and regulations. So pin planning will be checked here, right? Along with other things, but here specifically for this lab, for this experiment, it will check specifically pin planning. So that I have selected, right? So here you can see one warning is there, that is coming from the PS, not from the PL. So that means that is fine. There are no such violation as such. So this is coming from PS. PS is the ARM processor connection. So that I don't need to think about, because from the PL side there is no warning, right? So what I will do, I will run synthesis, run implementation, and generate bitstream. So I'll directly click on generate bitstream and click on yes. So the bitstream is getting generated. So any of the participants who is interested to run your designs onto the FPGA board, please come up with a bitstream. so that you can I'll let you know how to do the VPN connection. From the VPN, you need to connect. So that means you need to connect your system to the Sandipani's network. From the Sandipani's network, you need to access the board. So that is the flow, right? So
Sir,
yeah, 1 second. Just let me complete. I think Arun sir has provided you with the VPN software. You can see this mail has been provided. So that you need to download. Once it and it will need to get installed. So in the taskbar, this Open VPN GUI icon will be there, right? There you need to click. Then you have to provide this username and password. Then you will be connecting with the Sandipani network, right? Yes, tell me.
sir, once can you show the demo how to open that VPN? Like I am getting some error.
Yeah. So that's why because it's my Linux machine, right? So this flow will be different. So can you share your screen by that time, since it is Bitstream is going on, right? So it will take some time. You can share your screen so that everybody can have a demo on it.
Sir, now it won't be possible because I'm connected with my phone.
Okay. So that's why like if anybody wants to, because my interface is on Xilinx, right? Sorry, Linux, right? So this is like most of the participants have in Windows, right? Anybody has installed? Okay. So Abhinav, can you install? So tomorrow we can have the demo. Is it fine?
Yes, sir.
Tomorrow can you connect?
Sir, I have installed. I can
Yeah.
show by the end of this class. I can share the screen.
Sir, I have
Yeah.
already installed.
Yeah, sir. You can share your screen, sir. Abhinav, we can check here, right? Yeah, sir. You can share your screen. Ranjan, sir, you can share your screen, sir.
Sir, it give permission to share, I think.
Yeah, sir. You can share directly. No permission is required.
When I share it, entire
Uh-huh.
screen. Okay.
Yeah. Yes. It's coming,
Now it
sir.
is visible.
Yeah, it's visible, sir. Yeah.
Now, yeah.
Yes. Correct, sir.
When I
Here,
click it,
yeah.
it is showing the username and
Yes,
password.
correct. Yes, sir. That username and password is also provided. You can check in your mail.
Okay.
Just you can copy and you can paste. No worries, sir. You can go to that mail that we have provided.
Okay. Now I'm running. Today it is not possible.
Okay, fine. So this is the thing. Only you have to connect today. Only it's possible if you have this one user ID and password. You don't have, right? You have,
No.
right? No. We have already provided, sir. Check your mail. Yeah. So yeah, here yes. Arun sir's mail. No. Arun sir's mail. Yeah. Correct. So here you can. This is the user ID and password. No, not this one, sir.
And that is a exe file.
Exe file. Go up. Yeah. So this is the SOC. Yeah. This is the user ID and password. No,
Yeah,
not
yeah.
this. Yeah. No, not required. Not required to
No.
download. Sir, already you have
Okay.
downloaded.
Okay. Actually, that is a link. User ID password where it is given.
Yeah, sir. Here, sir. Go down. No. Yeah. Go up. Yeah, you can
user.
see user.
That's okay,
Yes.
user. Yeah. Okay.
Yeah. Same thing
Okay.
everybody need to do. Yeah. So you can connect VPN now.
Okay.
Sir, I have copied those that username and password. Still, that I'm getting error. After that, only I'm getting error. Some error.
Yeah. Let's see that. Sir, can you type it out?
Okay, sir.
Yeah. Okay, I'm sending it in Teams. So yes. Okay. So can you this one? Can you open? Yes. It's now connected. So how to check it now? So let's say like before going to implementation and Bitstream, I need to see the connection has been done or not. So what you need to do, you need to open TCL. Sorry, you need to open command prompt. So in search, you can open command prompt. In
Where,
search,
sir?
so in desktop, you can open command prompt.
I have desktop. Okay.
Yeah, means in the search option is there, right? Go down.
Mm.
Go down, sir. Yeah, go. Yeah, in programs. Yes, sir. Here you can type. No, not here. In programs, sir. Yeah. Command prompt.
Command prompt. Yeah.
Yes, yeah, this one. Okay. Now you type ping, ping, ping.
PI.
Yeah, ng. Yeah, space. So I'm giving you an IP address. Just I need to check 1 second. Just let me connect with this one. Yeah. Yeah. So you type 192.168. Okay. Then 0.0. No, 168 dot 0 dot 62. Yeah. Click on enter. Click enter. Yeah. So that means they are sending certain test messages, and you can see this ping is available. You can see this is 100% communication for communication. Now that means you can easily connect to my system. So this is the remote machine to where the system is connected. So now you can open Vivado. So you open a new folder in Vivado. Yes. Yeah. Okay. So here itself will add sources, add and create design sources. Yeah. So you go back to today's this thing like the files that I have provided today. Yeah. Correct. Yes, sir. Yes, this one. Sir. Yes. Sir.
Already it is downloaded.
Yeah. So you can extract it. Yeah. Yes, sir. Correct, sir. Yes. So you here itself. So what you can do, yeah. So those things you need to add, right? So yeah.
Yeah.
So you know where
Okay.
it's download. Yeah.
Okay.
Yes. So you add it, sir. Yeah.
Yeah. Sir, better.
It's in downloads, I guess.
Yeah. Keep in desktop.
Yeah, okay. Yes, sir.
Sir, taking some time.
No worries, sir. So same process, everyone we can do that.
Yeah.
Yeah. Sure. So
Yes, sir.
just
Now
you
it's
can.
running.
Okay.
Yeah. You can search where you have placed.
No, sir.
In the desktop, it is not extracted, sir.
Yeah. Actually, previously, madam told.
That no, it's a new like new files we are doing, right? So that's why.
Yeah.
Yeah. So you can directly go to
Okay.
download, sir. Yeah.
Okay.
You can go back.
This is download file.
It's in, correct. In downloads only, this source code, this one is there, right? So that you need to add. So you copy it, you copy it in a place where, here itself,
Now it will be open maybe.
yes. So it's there in the third the one, right? Yeah. First you copy the source code, so clock divider, first and second one,
First and second.
yes. The two files are required, right? One is clock divider and one is proper counter. Click on OK.
Both at a time.
At a time, n number of things you can copy, and both will be included at a time only. Just you need to copy both. Control. Okay. You can see both has been added. Then finish. So design sources are there. So you need to add the constraint file. So here add sources. Add and create constraint. Add files. XDC. No, XDC file here. Okay.
XDC.
Yes.
XDC file.
That is done. Now what you need to do, you need to generate the bitstream, right? So both are there. You can see, and XDC file is also there. Go down. No, in the sources only. In constraints.
Okay.
You can see both. Now you can directly generate bitstream. Go click generate bitstream. Yes. Click on generate bitstream. So let it run. By that time, what we need to do is, So now you can stop sharing. I'll give you I'll give
Okay.
demo from. So once the bitstream is generated, you let me know, sir. You can share your screen, and you will be programming it onto the board. Okay.
Sir,
Yes. Shivam, there is a question, sir. Only two cables are connected to board. Two cables in the sense? Shivam, what is your query? Hello. Okay. Abhinav, tell me. I have. Okay. Understood. So
sir,
so
can
this
I?
is a good question. Let me complete. Abhinav, 1 second. So you can see, Shivam, you have two cables, two programming cables, this one, right? So one is for UART connection that is connected directly to the PS, and another is to connect this one. So I'll just share my. I'll switch on my camera. Is my camera visible? You can see. So this is what you need to connect near the this one. So this is what you need to connect. So this is the USB JTAG cable. So through this USB JTAG cable, we'll be programming. This cable you can leave it vacant for now. We'll be using this for Zinc SoC. Is it fine, Shivam? Okay, fine. Thank you. So then for you don't need to connect VPN directly. You can program. Once the bitstream is generated, you can directly program. Shivam. Okay. Abhinav, tell me.
Sir, can I share my screen?
Please share your screen. Same thing you have done, right? Let's see, what is the issue?
Is my screen visible now?
It's loading. Just give me a second. Yeah.
Sir, I
So
have
here you
generated
can see
bitstream.
bitstream generation error. No. Wait. Before that, you can see bitstream generation error is there. You have to
Yes, sir.
close hardware manager. Close hardware manager.
Yes, sir.
Yeah, go to messages. Yeah, just strike off this critical warnings and warnings.
Sir,
Now go. Just you unselect. You keep message. Yeah. This thing and this warnings also you unselect the warnings and unselect the infos also, so that I can concentrate on the errors. Right? Yeah. Okay, so you can see here, yes, yeah, I got, so you can go down. So you can see this is a print planning error. You should have checked DRCs, right? So address and LED, these are not connected, right? In XDC file issue. So you can see here your top module is ROM. Your top module should be LED top. Right click.
yes, sir.
Yes. So right click on LED top. Yeah, right click. You select as set as top.
Oh, that's why, sir. After that, I won't be
It
getting
is,
error because I have
yeah.
added all the constant file.
Yes. So yeah. So but since your top module was different, right? So that's why it was
So
happening.
now I have to again run synthesis implementation, then
Yeah.
get able
Yes.
to stream.
Wait. That's why we don't know any kind like there might be other errors also, right? So better to check for DRCs. So go down. Just let me check the constraint file.
Yes,
Wait. Let me check the constraint file. Just scroll down. Go down. Abhinav, go down. No, not this one. In your sources.
source
Go up.
yes.
Yes. Source XDC file. Just let me have a look. Okay. Oh, fine. Okay. Go down. Yeah, fine. So let's open elaborate design. Click on open elaborate design. I'll check. We can check directly here if there is any error. Yeah, click on OK.
Sir, actually, my processor is very slow, so it will take a time. After during
Okay, so
synthesis,
what you
it may take
yeah.
5 minutes. May take.
Okay, fine. So just before that, what you do when open elaborate design is done, there is a run XDC option is there. Run DRC option is there. Sorry, run DRC
Yes,
option
sir.
is there. Just you click
Yes,
that
sir.
and you evaluate it. One warning will be there, but there should not be any other critical warnings or critical warnings.
Okay, sir.
Fine. Okay,
Yes,
fine. Just to let me
Thank
know
you,
after
sir.
that. Yeah. Okay. Fine. So first, what we will be doing, I will be showing you this one, a demo on my machine directly. Then Ranjan sir will be demonstrating on a remote machine. I will be giving the steps. Okay. So is my screen visible?
No, sir.
Is it
No,
visible
sir.
now?
No.
Upload speed is quite less. Okay, 1 second. Then. Yeah, is it visible now? Hello?
Yes, sir.
Yes.
Yeah. Okay. So this is the same step that you need to follow. So open hardware manager, click on OK. So open. I think already ma'am has demonstrated that. So we'll have a glance on this. So here, what I will do, I will select remote server in case like Shivam, he has the Z board with him. So he doesn't need to connect through VPN. He doesn't need to connect through remote server. Directly, you can select local server, and only this JTAG pin should be connected. So from the JTAG pin, this one will be programmed. So there is a J20 pin program is written here. Just I am showing it here again. You can see here. So this is the JTAG pin. You can see here. This is program option is there, correct? So that pin only you need to connect to program the TL side of Zinc board FPG, right? So only this thing is required, right? So that we need to connect, and we have to switch on the device. The device is switched on. Then I'm clicking on next. I'm searching for the device. Okay, so it has selected that particular device. Then click on next. Then click on finish. So once I have selected it, what I need to do is, so you can see here ARM and this FPGA is there. So ARM NA, because we cannot do hardware programming on that, right? So we can do programming on this particular 7 series FPGA only, right? So that I'm selecting, and this is the bit file. Automatically, it's there in the folder, in this particular folder that we have, that the tool creates. I'll click on program. So once I have programmed, you can see here, I'm switching on my video again. Yeah, so you can see here. So this is the reset one. This is asynchronous reset, right? So by default, it is down count. So I'm making it up. I'm switching it and resetting. You can see here at every second, close to 1 second. It's not a real time clock, but close to 1 second, the count is incrementing, right? So you can see here, I want to decrement it. I'll just switch switch it down. You can see the count is decrementing. So this is what you need to do, right? So this is the full flow from RTL to Bitstream. But in case, since you like the participants doesn't have the board connection, they can connect it through VPN, through remote access. This is only for remote access, not required for this one. Like it's not required if you have the board with you, right? Okay, fine. So what we'll be doing now, Ranjan sir will be connecting to the device, that is to the server computer through which he will be programming it, right? So sir, is the Bitstream is completed? Bitstream generation?
Yes, sir. Bitstream generation successfully completed. So now I share my screen.
Yes, sir. You can share your screen, sir. Yeah, you can see
Open
here.
Hardware
So
Manager.
same thing. Yes, correct, sir, correct. Open Hardware Manager. Yeah, not autoconnect. Don't do autoconnect, sir. Open new.
Open.
Yeah, correct. So remote server. Yeah. So now you have to connect 192, that same IP address.
192.
So these things, it should be one by one. Like this, since Ranjan sir is working, you should not use the tool to connect this one at that time. So only one by one needs to be connected. Yeah. So you can see the port is constant. Yeah. Click on next. Now it is connecting from Ranjan sir's port. It is connecting it. Okay. So that's why I told to. So you have 20.
Yeah.
20. Yeah. So if it is, so my system is, so that's why like I'm working on 2020 dot. So if you connect this, so after that just you need to program. So that will not be connected because the version is different. You can see, it's an older version. Okay. So that is an issue over here. Okay. But this then you just need to program. So do you have 2020?
Actually, in my actually this is available in college. So no, actually this is downloaded 2022. So I have
okay.
In my PC there is 2020. So the tomorrow I will connect to my PC.
Yes, sir. So what you do, sir, whenever you are free, you can give me a time frame and you can let me know. I will be I'll be giving you the details and you can connect to a machine, sir.
Okay. So after the host name, then the next it will be connected automatically.
Yes, it will be connected automatically. Nothing else.
Okay. Tomorrow
Then you
time
need
that
just
will be give.
yeah, you can like whenever you are like you are in your system, like just let me know. I'll give you the details in Teams, or you can in mails. You can just ping me. I'll give you the details of the host name and the port number, but the
And
VPN
time.
settings will be same.
Yeah.
And time,
Okay.
yeah, it's the time you give. Like whenever like
Okay.
I will be just you ping me. I'll be giving you that like if I'm available within a five, just like 5-10 minutes process on.
Okay. Okay.
Okay, okay. Yes, yes.
Excuse
Yeah,
me, sir.
Abhinav. Yes, yes, please.
Sir, sir, actually, I'm not able to connect with the VPN.
Yeah, can you share your screen?
Yes, sir, I'm sharing.
Sir, I
Yeah.
will now close my screen.
Yes, sir. Yes, sir. You can stop sharing, sir. Thank you.
Is my screen is visible?
It's loading. So your firewall should be off.
Sorry, there is
Sir,
something TLS hands up
Is there
state
any
and
antivirus? You have to disable it.
no.
Firewall
sir,
will
I
be.
have that solution.
Yeah. Yes, yes, yes. Please,
Sir,
please, please,
because
Abhinav. Yeah,
sir,
yeah, Shivam, I guess. Yeah.
actually, if you're using a college LAN, it won't allow. We
Yes,
have to
yes,
use
sir.
our own
Sir,
internet.
sir, I am
Ha,
also,
ha, ha.
sir, I
Yeah.
am actually using the same Wi-Fi. I'm also expecting the same
Yeah,
error.
yeah.
I mean,
You have to use your personal
yes,
network.
sir.
Plan.
Sir,
Okay. Yes, yes.
sir, can I share my
Yeah,
screen?
yeah.
I have the same version.
Yes, yes, yes. Please, please. Yeah. Great.
Sir, I have
You can share
generated
your.
the like bit
Yeah, yeah,
stream.
correct. Correct. Okay, so this is MAM's lab, right? So this is also a counter only, but it is
Yes.
giving the data from a ROM, right? So same thing, yeah. So Open Hardware Manager, correct? You have ping, you have tried to ping it once.
Yes, sir,
Fine,
I
fine.
have
It's
connected LAN. I
okay,
have
connect.
connected the VPN.
Yeah, yeah. Fine, fine. Open new target. Yeah. Remote server. Yes.
Sir, is the IP address correct?
Yes, yes, correct. 162, right? Yeah.
Yes.
So it's over the internet, right? So it takes some time. So we need to just wait. It will happen.
Yes.
Sir, I have connected what is the in the ping, so that's why it is maybe a problem. I will can disconnect.
Yeah, yeah, sir. If you are connecting, then no. If just don't ping it, sir, because multiple ping might create an issue, sir.
No, so actually in the previously I have initially connected. Now,
Okay.
so that's why I think that first
No,
we have
it
to
will.
disconnect. Then
No, ping. No. VPN you can connect many to one,
okay,
but this hardware manager is only one to one. VPN you
okay,
can
okay,
connect, not an issue, sir. So
okay,
this is multiple device connecting to this one Sandipani's network. That is not an issue, but this
okay.
hardware server this should be one to one. But since it is like over the internet, so it takes some time, but not that much of a time. But it's not showing any error also as of now.
Sir,
Sir,
tomorrow I will try
it may
for
be because
yeah.
Yeah. So, can you open command prompt? Yes, sir. You can, whenever you are free, you just ping me. So we'll discuss our availability, and I will be giving you the details, and you can log in tomorrow with 2020.1, sir.
Okay, 2020.
Yes. You ping. Abhinav, just can you ping?
Ping.
Yeah, PING.
Yes,
Space.
sir.
Yes.
Yeah.
That IP address again.
Yes. Correct, sir. Correct. Yes. 192.168.0. Yeah. Yeah, it's connecting. Okay.
Sir, it may
So
be
hardware.
because of I'm using my phone internet. That's why I suppose.
Yeah.
Yes, sir.
Yeah,
Now it's.
yeah, that is the reason actually. So, okay, fine. At least it got connected. So let's wait.
Yes, sir. Then, so next,
Yeah. Wait. So it's still up there. Yeah. Click on next. So it has
finish.
detected this one. Yeah, next, then finish. Yeah.
Sir, is my screen visible?
Yeah, it's lagging also.
Yes, sir. Because of my phone internet. I usually use
Uh-huh.
LAN.
Okay,
That's
fine.
why.
No worries. But it's connecting. No worries. Just we have to wait. Yeah. Now program device. Go up. Yeah. Correct. So that bitstream is there, right? Yeah. Just you program. Yeah. So it will be a bit slow process, but it's quite okay. Quite good. Then.
Sir, how can we see the output like in physical hardware? We can see the LED blinking. Here, how can we
Correct.
see?
Yeah, so for that, if you want to see, I have to show you in this one, in a video. I have to open the camera, right? Okay, it has been programmed. So I'm opening my camera here. I'm switching on my camera. So you can see here, right? In
Oh,
This is my
this is
camera.
my code. Okay.
This is your code that is burned. So you can see, but what is happening? So I'm showing
Yes,
it
sir.
here, but it is not visible to you. So that's why you can have ILA and VIO. So ILA and VIO from your screen only it will be visible. Yeah, understood, right? ILA and VIO, these are debug cores. So those data will be going directly to your system because through your system, the board is connected. You got the point, Abhinav? Hello? Yeah, I guess. Abhinav, are you there?
Yes, sir. Sorry. Sorry, my
Yeah.
internet
Okay,
got
fine.
disconnected. That's it.
Okay, so that is the thing. So what you need to do is like if you have, we'll have one more session on ILA and VIO. So that information directly it will be reflected on your screen. Fine. So that thing we can do. So just like tomorrow, just come up with a good internet so that it will be easier for like for you to demonstrate ILAs and VIO connections. So that thing,
Yes, sir.
because those information will be sent from the FPGA to your tool, right? So you'll be seeing that interface, but the process will be same. The process won't be any different. And
Yes,
what you
sir.
can do, you
Understood,
can
sir.
control, you can control this triggering, you can control inputs, and you can connect, and you can control the FPGA from here. So that is the advantage of using remote. Is it fine, right, Abhinav?
Yes, sir. Understood. Thank you.
Yeah. So yeah, Sivam, Jetboard is not connecting. Can you share so that I can have some reference?
Yes, sir, I will.
Yeah. Yeah, you can open your this one also camera also. You can see I can see the connections and why it is not connecting. You can share the screen of the tool. Open hardware manager like that.
Okay, so 1 second.
Yeah, please.
So are you able to see?
Yes. So you have your own board, right?
Yes, sir.
Okay. Fine. So open target.
Give 1 second, sir.
Yeah, no worries.
sir. I think my
Your drivers are proper, right? USB
yes, sir.
drivers. Yeah.
These
Yeah, but
boards
this
are
please.
these
Yes,
boards I
tell me.
got from college, sir. So I
Okay,
don't
okay, okay.
know exactly.
Okay. Fine, fine. Let's check. So open target.
Sir, yes, sir.
Yeah,
Open
open
new
new target.
target.
Yes. Yeah. Local server, fine, because you have hardware. Fine. Next, let's connecting to the server.
This is the one. There's nothing coming, sir.
Okay, so let's see this one. Can you open control panel device drivers
So here,
in control panel of your computer? Yeah, because those drivers, right? USB to this UART drivers should be
Sir,
proper.
maybe driver cable not properly installed.
Yes, yes, that is what we're. So driver software device drivers should be
Cable.
installed, right? Yeah, yeah.
Driver cable may not install. That's why maybe some cases.
Yes, yes, that is the
In
reason.
our
Actually.
college
So,
also we are facing same problem.
yeah, yeah. So, so what you need to do? So, can you open control panel?
yes,
Shiva?
sir. I have opened control panel.
But still, the screen is freezed actually. I think you have shared only
Okay,
this screen. You have to share desktop. Yeah.
okay. Okay, sir. 1 second.
Yeah, yeah. So I am providing you the softwares for the device drivers also. You can take it for reference also. That will be
Okay,
good.
sir. Thank.
But you can share. You can share. We'll check it. We'll decode that problem also.
Okay, sir. 1 second.
Generally, in the newer versions, these things are not required. But maybe check.
Sir, I have Arctic 7 tomorrow. I will try in college. Actually, only Arctic 7, no Z board. So
Okay, fine. So Arctic 7 also you can do, but that number of LEDs and
yeah,
these things should be same.
I will try coding and writing. If
Sir,
there
can you
problem
give me
after.
the board number? This one. Yeah, those things should be changed as per the requirement. So can you give me the this one Arctic 7 this one, right? A705, right? This is the board, right? Arctic 7 evaluation board,
Arctic
right?
7 basis 3.
You have basis 3 board, right?
Yeah, yeah. In
Basis
college
3 board.
actually it is available.
Yeah. Basis 3 board will work. No worries.
Okay.
Okay.
Tomorrow I will try.
Yeah. You can try. Just you have to change the XDC file, though.
Okay, okay, okay. Okay.
Yeah. You know the flow, right? Same thing you need to do. Yeah. Yeah, Shivam, you can check control panel. Is the device connected? Device
Sir, tell
manager,
me
you have to.
which fault.
Yeah.
Tell me, I will do that. I think I'm not
Okay.
able to share, sir.
Okay, fine. So you have to go to control panel. In control panel, you have to go to device managers. In device managers, when you connect, you have to see that connection happened or not. So let's say I'm giving an example. Let's say you connect a peripheral. Let's say you are connecting a joystick. So
Yes, sir.
there will be device drivers that will be installed automatically, right? So that thing you need to see. So if it is
So,
installed,
sir,
then yeah.
then in what
In
way
which
it will? What's the name it will come, sir?
it will be this one. 1 second. It will be USB UART device drivers like that. The USB UART kind of a name it will come.
Sir, can you show me yours?
No. For me, it is this one, right? Yeah. 1 second. I'm sharing my screen better. I'll give you a. Yes. Because my system is in this one, right? So Cypress serial. Is my screen visible? So this is what you need to check. Is my screen visible?
No, sir.
1 second.
No, sir.
Uploading one. Yeah, is my
No, sir.
1 second.
No, sir.
Uploading one. Yeah, is my screen visible now?
Yes, sir.
Yeah, you can see here. So this is what you need to see. Type in your device drivers. You can see ports. Cypress serial should come.
Okay.
Okay. So this thing I am providing you. Yeah. So you can see this is the link. Just to install it once. We'll see tomorrow if it is not solved yet. And which pin you are connecting? You are connecting this one, right? Which is between the
Connecting
power
to the
cable
power
and
cable,
the
sir.
now.
Yes.
1 second.
No, sir.
Uploading one. Screen visible? This one, right? Yeah. 1 second. I'm sharing my screen better. I'll give you a. Yes. Because my system is in this one, right? So Cypress serial. Is my screen visible? So this is what you need to check. Is my screen visible?
No, sir.
1 second.
No, sir.
Uploading one. Yeah, is my screen visible now?
Yes, sir.
Yeah, you can see here. So this is what you need to see. Type in your device drivers. You can see ports. Cypress serial should come.
Okay.
Okay. So this thing I am providing you. Yeah. So you can see this is the link. Just to install it once. We'll see tomorrow if it is not solved yet. And which pin you are connecting? You are connecting this one, right? Which is between the
Connecting
power
to the
cable
power
and
cable,
the.
sir.
Sorry.
So near to the power cable, that pin, that.
This one only you are connecting, right?
Yes, sir. Yes, sir.
Okay. Then it should come. You have switch on the power also. Then it should come. And you check the power cable, like USB cable also. Sometimes if USB cables are not proper, you can change the USB cable and check. It will work. Any USB 2 type of any kind of 2 type USB 2 protocol it will work. Just you check those things, okay? Or else we'll have a discussion tomorrow.
Okay, sir.
Okay. Thank you.
Thank you.
Okay.
Sir.
Yes, please.
Sir, during debugging through VIO and ILA, we need the device to be connected to our like Xilinx to be connected to that device.
Yes, because VIO and ILA are real-time data you are getting from the device, right? So it should be connected, like the device should be connected. Should be connected to your remote machine or your local machine. It should be connected. Otherwise, there is no point, right? So you cannot check what is ILA. Internal to the design. After the design has been implemented, from there we are extracting the data, right? So it should be connected.
Yes. Okay, sir. Understood.
Okay. So tomorrow we'll have one more demo on ILA and VIOs. We'll have a 32-bit 32-bit counter we'll make. So because the LEDs will be less, right? So we'll be using ILAs and VIO to see that, and it will be real time. You can also do it the same thing, right? So we'll connect tomorrow. We'll have one more session on ILA and VIO, and we'll have practical sessions like this, right?
Sir,
So
my
tomorrow,
drivers are not installed, sir. How can I do that?
yes. So that document I have provided, right? Just check that document. So there is a link for the installation. So one file is provided here, there, device drive. You can see here in, I'm sharing my screen. Is my screen visible? Shibam?
Yes, sir. It's
Yes, sir,
visible.
visible, sir.
Yeah, I can see.
Yes,
so just you need to click here. So that will take it to your USB that driver, right? So that you need to download.
Okay, sir. Thank you, sir.
Okay, fine. I'll give you a link anyways. I'll giving you a link in this one, the download link in the mail itself, so everyone can download. Okay, I'll give it in mail, the link to download the this one, to download the device driver for this USB. Fine. Okay then. So we'll connect tomorrow. We'll have more experience on that. Then we'll move to Zinc SOC. Is it fine, everyone? Yes.
Sir, when we can
Yeah.
access the board, like you were saying this.
Yeah. So that's So tomorrow, just ping me whenever you are ready with your bitstream and you are ready with the setup. Just ping me. I'll give you the IP address and the port number.
Sir,
And I'll
actually, my it is required for my MTech thesis project. I'm doing my project on the Zybo board also, but actually there is some problem with the resource. If it will be possible to check in the Z board, then it will be very much helpful for me.
Yes, correct. So what you need to do, just you need to download the master XDC file of the Z board. Correct. So I'm showing you for how to do it in Z board, right? Sorry, Zybo board.
Sir, that but I can do it. I mean, sir, I have already implemented in the Zybo. Sir, the
Correct.
problem
Then
is the resource utilization. Like in Zybo, the gate count is, approximately 17,000. So for me, the gate count is more than 30,000. So that's why I need to check on the Z board.
Yes, correct. So that means
can
your
I
project that
access
you
it after
are
the
implementing.
internship is over? Like.
So what you do, there will be 1 week for implementing the project, so you can use the JetBoard to implement it. This means you need just JetBoard to use your project, right?
Yes.
Okay, so that you can do.
Yes.
After the internship over, we'll be giving 1 or 2 weeks to for you to work on the project. At that time, you can access.
Yes. Thank you.
Yeah. Just give me a mail so that we'll be in loop. Just I need to access the JetBoard. Can you please give me a time? So I'll be giving you the IP address and the port number, and you can access.
Okay, sir. Thank you, sir.
Okay, fine. Okay, fine. Then we'll connect tomorrow, and we'll have a look on ILA and VIO. Yes, Abhinav.
Sir, up to how much time that Vivado license is valid?
Yeah, Vivado license is valid till this one 1 month.
Okay, sir. Okay, sir.
After that, you need to contact your department, right? So department license will be available. College license will be available, right?
Okay, sir.
But sir, this is for the license. I think we didn't connect any license to Vivado 2020.1. For HLS and others, it was like 30 days.
Yes. For Vivado also, its starting is 30 days only. But for some basic devices, it gives license. But for if you are going for a bigger device like Arctic 7, evaluation board, and this one, so it is basis depends on device to device. Is it fine? Okay. Okay, then we'll connect tomorrow. We'll have a session on ILA and VIO. Then we'll move for Zinc. Thank you, everyone.
Okay, sir. Thank you.
Thank you.